So hello, we're going over SAT Math. This is a review for car depreciation and one of your biggest ones, exponential decay. A lot of the problems on the SAT and on the ACT do not show exponential decay as a word problem, but they do show it as like something needed for either car depreciation or home depreciation. So we're going to go over it. This is the basic formula, y equals c. C represents a constant, and then of course you would go c times 1, which is 1c, equals cr. R equals your rate. And your rate is the rate of growth or decay. So here are your domain values, and keep in mind, if you get on a test, even if you have a test with your teacher, your range is y. So these are all your range values for a given function. And remember, function is usually recorded as y equals f of x, or sometimes you'll have it written in this way: f of x equals 2x plus 1. Might be something simple, but it's always written as a function. It might be something a little bit more complex, like f of x equals 2x squared plus 4. And your teacher can get into how this constant will probably go up or down, or it will be that maybe there'll be, as long as this is positive, an increase of 4 along the graph. Just keep that in mind, and your domain is pretty much all of this. So if you get confused and you forget what your domain is, which are your x values, just try to remember what your range is and think of a range as going up. When you're driving on a mountain range, you're going up. So I should really erase this. I should probably, if you want to think up, just think of try to get as much as you can as going up. Just remember your range or your y values. So we move on. Now, if we wanted to record this y equals f of x, we have y equals f of x, and we would record these values. So I'm going to go over here and I'm going to write y equals f of x. And all this is telling you to do is put a function that is going to make these values give you a value here for y. So y is going to equal f as a function times 0, because x is the only thing that you have to replace. When you multiply this out, you're going to get y equals 0. So you have that here, two values, 0 for x, 0 for y. So when we go over, we get ready to replace those. We have an x function here, so it would be f of 1. Then you have f times 1, and since you don't really put anything here, y equals 1. Now, why aren't we doing this? F just means function. Okay, so y equals 1, you have this here. Do you pretty much get the follow-up here for what's going on? You get pretty much that no matter what you do, when you have y equals f of x, function of x, you can even go over here and erase this, and you can just go on ahead and put 2. I like to keep the f there for a while, but you can put 2 here. So this is saying when f of x, when x is 2, y is what? 2. So you have 2, 2. So that's why you have the chart. So here you have a straight line, and you see this. You see your points here when x is 0 and x is here. Y is here. When x is 0, this is 0. When x is 1, this is 1. When x is 2, this is 2. So don't let the terminology of decay, growth, or any of this confuse you. Just remember they're written out as functions. Now we're going straight into equations, and I'm sure your teacher has told you that if you have a linear equation, like here you have a line and you can have the same values. This is just showing you the slope, and your slope is y2 minus y1. So they put these values in here without like showing you the slope. So here you have a quadratic equation here because you have, what is the term used here? You have a parabola. People who speak Spanish, you don't have a hard time with this, right? Because you know parabola means for or toward a bowl. And here you have an exponential function where you have right here is growth because it's going upward. If it were here and it was going like this, you would see that it would be moving on a constant rate and that it would be going downward. Okay, so you have the green one that is going up, and whenever it's going up, you have growth. And whenever it's going down, you have decay. Okay, I'm going to write this in red. What are you guys doing with decay in science? Don't you guys do radioactive decay? You also do fossils, and that's the term there is radioactive decay. So guess what? Okay, so down is down and up is up. Okay, this is just something here, either completely increase or decrease. Usually that goes at a level, and then a quadratic equation, the graph goes, it goes up at a certain point or it comes down at a certain point, and then you have what's called an automatic minimum. This is your minimum point here. And you're going back up again. So that's why I wrote it like this. The graph, okay, this is unlike the quadratic function because that's what the quadratic function does. Okay, so now that you have what your graphs look like, let's try to look at this. This is a problem actually taken from one of the ACT books, and we changed the year around, and we changed this number around. But it's like in 2004, there were 395 households with cell phones in the small town of Pleasantville, Ohio. The number of subscribers increased by 75% per year after 2004. How many cell phone subscribers were in Pleasantville in 2013? Now, in order to solve this problem, first thing you need to do is you need to figure out what you're going to put here, and I'll discuss this in a second. That's going to be 75%. Some people will turn this into the fraction of 3/4. You can, but I recommend you don't, because then you have to remember that this is going to be 1. Your constant is going to be 1 plus 0.375. And your numbers may come off differently. So I wouldn't do it like that. Okay? You could also remember that this is 1.25, and you could do it that way too, and then start subtracting. But anyway, now the second thing you want to do is look at how many years went from 2013, because they're asking you what is it now, to 2004. So like most of your problems, they're not just one way. Let's have a good time. Just remember, you're doing 10 things at once. Break them down, do them slowly, and don't let them scare you. Okay? So you have 2013 You're borrowing, that's a 9, comes a 0. So that's 9 years. Now, why is that important? Because that's a squared value, and we'll discuss that on the next slide. So 9 squared, which means that you are multiplying this constant times this number that many times to get an answer. So 175 is 3.06. Look at what you were doing. Now all I did was put the squares. When I get the final answer for 9, I have to do 153.9 times 395. And that gives me 60,790 and a half, because that 0.5 is really 0.50. Okay, but this constant has to be done each time. Some of you, when they do it online, they allow you to take the computer's calculator, and all you have to do is multiply 1.75 times 9, and that's going to give you this number automatically. But I did each one so that you can show how it goes from 3.062 to 5.35 to 9.3 to 16.4 to 28 to 50 to 87.96 to 153. And you can leave this as the answer might have 60,790 and just leave the decimal off, but just in case, that's your answer. So that was a lot in one slide, especially for people who are just getting it. Let's look at it as a car formula. Now here we're using a rate that's different, and what we're going to do here is look at what's going on. 15% per year. Exponential decay. Why are we using that? Because exponential decay for driving cars comes out as depreciation, and that's real. If any of you guys go on Kelley Blue Book, kellybluebook.com, some of you guys are juniors, seniors, you're looking for a car, they'll ask you, what is your depreciation value? They'll go, how long have you had your car? Because if you want to trade it in, or you want to trade your parents' car in, and get a new car, they'll say, well, how long have you had it? And so if this is your question, suppose you bought a car for $75,000. The car depreciates at 15% per year, therefore the car will not be worth the same amount as you purchased it. And I just put this in general, cars depreciate. This car here, I think, is a Lamborghini Murcielago. It does not depreciate as much as a car like the Honda Civic does, and the Honda Civic is one of the better cars as far as lasting as compared to Rob Report says some of the other things say, but here's the situation. Whether it does or not, you're just looking for, in general, they depreciate, they go down, because once you drive a car, it's just like anything else, it becomes used. So how do you prove that the car is decaying, and how do you find what the car's value will be in 10 years? So you have to get a formula, which we already had. Now at the front I had it as C of R, I believe, but here we're just changing it. You're going to change it to P, which is principal, okay, and this T here represents time. All right, so I'm going to put time here. So I keep it in a bracket. Why am I keeping it in a bracket? So that you know that you have to multiply it. Now let's go to the next. This is what this slide, these are all the years. This is year 0. So I'm going to put year here. Y for year. I'm going to try to write it in here. So this is year 0, this is year 1, year 2, year 3, year 4, year 5, year 6, year 7, year 8, year 9, and year 10. And in case you forgot, they're all over here. They're just variables, x10. So you have your formula here, and you multiply it. It'll be $14,000. The answer to this question is right here, the $14,764.50. Okay, that's what it'll be. That's how much your car depreciates. So now we've solved exponential. And by the way, this would be decay, because decay means going down. Decay means losing values. You get a word from there meaning decadent. Okay, so you can even use this for formulas, like to think about how you would buy a car after 5 years. It's almost less than half the value of the car. So that's what happens why you don't have a resale value on some of your cars. Is after about 10 years, the dealerships don't really want them because they've lost value. It takes a lot to buy them back. So if you can just think along those terms. Anyway, real simple. Have a good day.